Hi, my name is Lucas Dumitescu, and I'm going to be running you through a data-driven business case study looking at smart agriculture and also looking more deeply at the Pictera satellite imaging platform. Smart agriculture is the use of things like IoT devices to create new data streams to create these value-added products to better manage the balance between supply and demand. So let's start with a project overview. So using the value chain, let's examine how we make this product happen. Collection is the first stage, and data is collected from a wide variety of sources. This could be sensor data or IoT devices, such as smart pumps, humidity sensors, temperature probes, or downstream manufacturing data. Engineering involves the ingestion and storage of this data. And governance is how we manage privacy, security, regulatory aspects, and data lifecycles. Wrangling is how we take data from all these different sources and combine it in a way that is normalized so we can then analyze it and generate insight from it. We then present it through things like web portals back to the customer or the end user. And operationalization is how do we actually put this into production using some of these sort of cloud services and providers. There's a number of roles that are required to make this happen. Data engineering is involved with the ingestion of data, so the collection and a bit of the wrangling. Data analysts are involved with the wrangling and the generation of those insights. Um, and lastly, data management roles are required to help manage that regulatory component and that life cycling of data, which is really crucial. So let's jump into what the Pictera platform is. It's a platform that lets you ingest imagery from open data sources like the Sentinel-2 satellite, which are two satellites that orbit the Earth, providing data we can see here, or UAVs and helicopters, etc. Here I'm showing how I use their platform to add some metadata to my images. You can see these purple annotations are houses. So I've gone in and annotated a number of houses. I then use this metadata to train a custom AI object detection model. And you can see that shown here where in the light blue, it's gone and found more houses automatically in all of that satellite imagery data. You can see how this process would be really valuable in agriculture for things like cattle counting, where it can automatically go through satellite imagery and locate cows, and then do statistical analysis on the location or the counts of those cows. A data-driven agriculture product needs to have a clear business model that underpins it, which helps it find potential challenges or areas that are really creating the value of this product. On the left, you've got the data providers, and those are those open data providers, user-generated or commercial sources. The data consumer on the right, which is the client and the consumer. You've got the application provider, which is Pictera and the steps of the value chain there. And you've also got the big data framework provider, which we're going to talk about a little bit later. The data curation and management is also a really key step. A lot of these applications suffer from drip, which is in smart farming where you have data-rich information poor. We have a lot of errors due to duplication in the data and throughout this ingestion process because things aren't normalized. Looking at the data characteristics, the velocity of the data, it's generally downloaded in batches for Pictera from these satellite sources or user-generated. But more broadly in the agriculture industry, it tends to be streamed from IoT devices or ingested in batch process from, say, downstream production facilities. The volume is pretty big. It's about 100 square kilometers is about 600 megabytes. And for example, the Google Earth database, which included satellite, aerial, and street imagery, was about 3 petabytes in 2012. The variety is very broad. In Pictera, it comes from satellites, helicopters, UAVs, etc. But in agriculture, it comes from these sensors and IoT devices and processes we mentioned before, so quite varied. The veracity in Pictera is very certain. It's geotagged, it's quite well known, but as we mentioned, for more broad agricultural applications, the data is not, the veracity is quite poor because there's a lot of error during that ingestion stage. Some of the resources that are available to build this kind of a platform are frameworks like TensorFlow for object detection, cloud platforms such as Amazon Web Services, Microsoft Azure, Google Cloud Platform for orchestrating the GPU and cloud services and storage. Languages such as Python and C++ are the most commonly used for these kind of applications. And data capture tools such as Drone Deploy and Pix40 can help stitch this imagery together to then load into the platform. The data analysis generally uses a faster RCNN or mask RCNN to do image segmentation to annotate the images like we saw before automatically. And that's a faster recurrent convolutional neural network. The discussion of how that works is out of this scope, but I've included the loss function to help see how this model calculates loss. The reason this is useful is because in TensorFlow they offer TensorBoard, and that helps you as you train the model over time, you can control over and under fitting of that model. So that's how all of these different processes, tools, resources, and business models come together to create a value-added product, the Pictera satellite imaging platform. And this is used more broadly in all smart agricultural data-driven products. If you're looking for more information, feel free to see the attached report. Thanks.